Bejeweled is a time-matching puzzle video game, with 10 billion hours on record and 500 million downloaded copies. Rules are simple. You have a board with colorful gems and you need to match 3 gems of the same color. Matching 4 gives you a power gem that explodes, and matching 5 gives you a rainbow gem which destroys every gem the same color it has been connected to. So, how do we even approach creating a board? To make stuff easier, we can divide it into 3 main steps: image recognition, movement calculation, and simulating the game. Let's start with the first one, being image recognition. For this task I'll be using Python libraries, which basically are pre-written code extending what Python can do. Now what we want to do is somehow gather information about placement of each gem. My initial approach was simple: create 64 points which would be somewhere in the middle of a gem. After that, compare them to a table with colors and create an array from this data, which then I could use to determine exact position of possible moves. However, there were 2 problems. In order for the player to be able to tell which gem is powered and which isn't, the game adds some various effects on the powered gem, such as glow, shine effect, and reappearing rotating star. As you can see, all of those effects blend in together, making powered orange gem look the same as yellow one. The same issue applies to powered white gems and rainbow ones. So what are the potential solutions? My first idea was to just take several screenshots and compare them if anything changed on screen. However, after some time of not playing the game, it started doing some animations like screen flash, and it also creates a blue arrow that might shift the results, so I had to change my approach. Another idea was born. I've decided to try dividing my board into 64 different pictures and then compare each square's average RGB value with a table that would identify the gem color. The issue, however, is that whatever color gem has, it also blends with the background, changing the results. The shift is big enough to remove the possibility of distinguishing powered orange and yellow gems, making this idea worthless. But what if instead of using colors, I would use shapes? Then I can have colors help me identify power gems better. For instance, I would count edges on each gem and then guess it by its number. Any gem that wouldn't match anything would simply be counted as a rainbow one. We would have a small issue distinguishing red and yellow gems, but at least we divided orange and yellow ones, which was the main issue. After playing around with libraries that shift gamma and contrast on pictures, I got some nice looking results. Then after trying to run some code that would count edges, I've realized that this idea will go nowhere. The main issue was that I couldn't get rid of the background, which was changing outcome heavily, so I tried to somehow get rid of it. I found one promising library that would help me remove background. Some test results were looking better, some less, but I decided to give it a shot, and unfortunately the results were pretty bad. Turns out that even playing around with board size didn't work. This tool simply was not made for a task like this, which you can clearly see on those worst test cases. After all of those attempts, I've decided to try one more thing, moving back to Bejeweled 1. At first I had some hopes in this game. It had a dark background, orange and yellow gems were having better contrast, and overall the game was really basic. In fact, it was too basic. Because besides combo system and moves, nothing else was in this game. No power gems, no rainbow ones. After thinking for some more time, it finally hit me. What if instead of trying to change what I see in the game, I'll just change the game itself? Turns out that all the sprites and a lot of game files can be easily accessed in the game folder. Obviously the first thing that I did was replace all the backdrops to black pictures. Game didn't remind me replacing them, so I also removed everything else that was bothering me. It turns out you can even replace PopCap logo with whatever you want. Now that we don't have those annoying backgrounds, we can again try our old ideas. We take a picture of a board, create 64 points that check for colors, and then create 64 more, which would be slightly offset, to check for power gems with some help of our new star sprite. After playing around for some more time, we finally resolved every issue. Image recognition is now finished. Going back to our steps, we can see that after image recognition, next one is movement calculation. This one was nowhere close as hard as the first one. It was just way more tedious because I had to code all 36 moves I could think of, so to save some time, I used the Yandef coding technique and I just made everything in elif statements. We are basically done with the basics here. However, if I would stop here, my code wouldn't be any better than those made 10 years ago. So we need some efficiency. The way how I achieve this is very simple. I analyzed entire board and went through every single move possible. Use some basic system to judge how beneficial the move is, rate them by which one is the best one and do it. That brings us to the third and the last part of our plan, simulating the game. To be able to determine which move is the most valuable, we need to simulate entire game pretty precisely. That includes rainbow and power gems. Simulating the first one was easy. I simply took 4 gems surrounding Rainbow one and then count how many of them are on the entire board, which would tell me which score to expect. The issue is with powered ones. Not only they can be triggered with Rainbow gems, which I needed to pay attention for, I also had to worry about potential chains of powered gems. You see, when multiple powered gems are one next to each other and one of them explodes, other will also explode, creating chain reaction. Trying to replicate that took really long, but here is the main idea. We create group of powered gems which are connected to each other. After making a powered move, we check in which group our gem is, and then we explode every gem from the group. After all of that, our code just needed last part, which is simply controlling the mouse movement and doing the moves. But then something unexpected happened. The game crashed. It wasn't any normal crash. The game decided that it had enough of me playing around and removed itself. I have no idea why, but all game files were just gone. Luckily adding them back took only 10 minutes and I immediately ran my final version of a code and it worked perfectly. This game mode compared to solving its puzzles, which would be in the next video, isn't really that interesting since it's just playing very simple game. I was thinking about trying to push its limits and speeding up the code to achieve some nice scores in the action game mode, but I think it would be the same thing, so just slightly faster. If you enjoyed the video, please consider leaving a like and subscribing. Also feel free to leave a comment, I would gladly appreciate some feedback. Thanks for watching.